Hey guys, so this is chapter 9.1 and 9.2. So this will be really like short and quick and nice. So not many things will be going on. So suppose we start with the data. Uh, I mean, you don't have to worry much about this. So it's a data with 200 people, men and women combined, and so it has like one part of the data is the sex, the actual weight, the actual height, and the reported weight and reported height. You don't have to worry about these two. I'm not considering them, and I'm only considering these three. So I have the data in my folder. So your data is just like this. Uh, so this is the column for gender, this is a column for weight, and by weight I mean weight in kg, and height, height in centimeter. Uh, and obviously each row is for one person. For example, the fifth person is a male whose weight is 68 kilograms and height is 177 centimeters. So with this data, let's forget the gender for a moment. So suppose I want to know the relation between height and weight. So basically I have two variables, x and y, and I want to know the relation between them. So what do I do? So one of the first things to do is draw a scatter plot. So what's a scatter plot? A scatter plot is just like this. There is a x-axis and there is a y-axis. In x-axis I have height in inches, and in y-axis weight in kilograms. Sorry, it should be height in centimeters. I'm sorry for that. And we have plotted the points. That's it. Like, what's scatter plot? You just plot the points, and that's it. So for example, for different data sets, suppose the scatter plot can be handy for many reasons. So it's one of the first graphical tools which shows you any trend in the data. For example, if the data is like this, then you know that this is like y equal to x square kind of data. You call it parabola, or you call it quadratic. So from this shape, or maybe from the data you can watch that it is something like this. So that means there is like y equal to cos x, some pattern like this, or maybe the data is just like a blob. By a blob I mean the following. So it's just a bunch of points and you don't know what to make of it. So the good thing about scatter plot is with just one plot it almost always gives you a first understanding. I mean, math comes later. First you have to like know which kind of math to apply. So That's an important point. So there can be many kind of situations, mathematical situations, but you have to know which of them to apply. So for example, for this kind of a graph, maybe there's one kind of math. For this kind of graph, there's another kind of math. But how do I know how to apply that if I don't even look? So that's why scatter plot is just about looking. You look first. Now the kind of graphs we are interested in is in this chapter is linear graphs. So that means where the points follow a straight line. Almost a straight line. So that's why this chapter is called linear regression. Now, several points. For example, we are not saying that all these points, we are never saying that all these points follow perfectly a straight line. What's a straight line? A straight line is like y equals a plus bx. I mean, I know that in your high school you learned y equals mx plus b, but forget that for now. Like, we'll go with a plus bx. So for now, y equals a plus bx. So we are never saying that y equals a plus bx. There's just one line through which all of them exactly follow. That means I'm not saying that. I'm not saying that the points are exactly fitting on a line. Exactly fitting on a line. This is not what I am saying. If such a thing happens, then it's like, I mean that's extraordinary. In real life, in real world, like if points fall exactly on the curve, like that almost never happens. So this is a rare situation. This situation is a rare situation. I mean, it's good if that happens, then that's good, but I mean that's a rare situation. So what am I trying to say? I'm trying to say so what am I trying to say? I'm trying to say that given points like this, if it looks as if a straight line, then that's what I want to approach. So if it looks like there is a line y equals a plus bx that can go through these data points, then that's what I can say. By the way, we all know that A is called y-intercept and B is called slope. So for example, if y equals 5 plus 4x, then 5 is the y-intercept and 4 is the slope. This we know. So we know that uh, for y equals a plus bx, this b can be positive or b can be negative. So that means b positive means it looks like something like this, where so as x goes up, y goes up. That means as x increases, y increases. And b negative looks like this. As x increases, y decreases. So the direction here, the direction is positive, and here the direction is negative. Okay, so now that's one thing. Now, so a terminology we just learned, direction. So the next terminology is strength. So for that, let me just put two things side by side. Call this plot 1, and okay, so call this plot 2. So now what I'm trying to say is, for both of these plots, plot 1 and plot 2, direction is positive, but here it's stronger. What's stronger and what's weaker? Let's see. And stronger in which sense? Stronger in the sense that all the points here, the linear trend is stronger. And here the linear trend is weaker. So you see that on plot 1, the points, obviously all the points don't exactly fall on a single straight line, but they are pretty close. And on plot 2, maybe they follow a straight line, but not so much. Like things are like moving around too much. So that's kind of an idea about strength. And it, like, the same thing can happen for negative also. So